think of joinery, there's basically one type of surface on wood that's good for glue surface, and that's long grain. So it's the sides of the fibers, whether it's the face of a board or the edge of the board, that's kind of irrelevant. But you can glue together mating surfaces of long grain to the point where, if you do it properly and the glue is appropriate, that joint, as simple as it is, can be stronger than wood, so that if there's a lot of stress on it, the wood will fail before the joint does. So there's not really any need for fortifying it with dowels and biscuits and splines. People assume that makes the joint stronger. If the joint is already stronger than the wood, then you don't really need to make it stronger than that. And there's nothing simpler than an edge joint. So you're probably more likely to do a good edge joint than you would be to do a good tongue and groove joint. So basically, if you want to create a panel and you want this surface to be flat, if you flip these two surfaces together and you shoot the edges with a flat plane, essentially flattening those two edges, they'll add up to 180, or a flat surface. So whether they're each perfectly 90 or not doesn't matter, they'll add up to 180. So, that's the first, basic joint in a sense, is just a butt joint. Could be face grain, could be laminated. The next possibility is to have face grain or long grain to long grain, but in a perpendicular direction. So now we have the possibility that the movement across the grain is going to, over time, weaken the joint. So there's some limit to how much width you would want. Otherwise, there's going to be some tension. And if you think about a 4x8 sheet of plywood, all these pieces over here, those are basically stable because they take thin pieces of wood and they laminate them together in a perpendicular direction. So the length of this freezes the movement of the width of this, and the length of this does the same thing to this board. So those are alternating layers of thin wood. So it's basically dimensionally stable because of that. With solid wood, if you leave some thickness to it, you'll have too much conflict. So you have to limit how much movement conflict you can have. But the idea is that we can do this, we can do this. We can't do this. We can't join the end grain of a board to the face grain of another, certainly not end grain to end grain. So anytime you need to connect the end of a board to another board, whether it's at that one, at the end of that one, face of it, the edge of it, we need to create joinery. So it's for any other type of thing other than basically laminating. And what we're trying to do is create long grain surfaces. In this case, the tenon is an extension of this piece, but this is not just a tab that goes in there, but it's a glue surface. It's a pair of glue surfaces that matches with the pair of glue surfaces on either side of the mortise. And so when this goes together, we have the mechanical aspect of it gives it some strength. As long as this whole shoulder is held tightly against the edge, it helps keep it from racking. The tenon itself in the mortise might help keep it from racking and from twisting as well. Nothing really keeps it, except a little bit of friction, from pulling out, except for the glue surface. So we need a joint that doesn't just look good when it's closed, but actually has good contact between those glue surfaces. So that's a pretty, basically you're going to have either mortise and tenon joints or dovetail joints or some variation through most furniture construction. Dovetails, same kind of thing. You have the tails here, and what we call the pins, which are the pieces and spaces between the dovetails. And the sides of the pins and the sides of the tails are the long grain surfaces. So now we have 1, 2, 3, 4 nice little glue surfaces in there, in addition to whatever mechanical strength the interlocking pieces have. And these two boards have no movement conflict because the movement is in the same direction. This is going to move across its width, and this is going to move across its width. With the mortise and tenon, we do have some conflict with the movement of this. Not this board doesn't want to let it move. So when you get situations like a piece of furniture like this dressing table, where you have these multiple tenons coming into this long post, again, this is not going to change in its length. This wants to change pretty significantly in its width. So if you look at some of these pieces in the museum, these will be cracked because this piece held this when it wanted to shrink, and something's going to give, so it's usually going to be this piece splitting along the grain. So you'll almost always see these split across the grain. And it's not so much that they didn't know that was going to happen. Probably there weren't the extremes